So you've done trapezium rule before. The trapezium rule was a way of getting approximate answers to nasty integration to find the area under curves. You did that in C2. This is an extension of it, it's an improvement of it. So if you just want to put a summary down, this is basically an improvement of the trapezium rule. So if this is an improvement of the trapezium rule, can somebody tell me in very basic terms, I know Tom did a minute ago, if I was integrating that and wanted to know that area, how would I have done it with the trapezium rule? What did I do? Totally blank looks. I don't want the technical stuff. Basically, what did I do? Split it up. Yep, okay. I split it up. Let's split it up there.
Made it into trapeziums.
Made into trapeziums. Yep.
And added up their areas.
Yeah, added up their areas, okay. Each of those trapeziums would be equal width, added up their areas. Here, have I under or overestimated my area?
Under.
Yeah, I've underestimated. There's a bit up there I haven't got. Here I would have overestimated, there I would have overestimated. So the trapezium rules joined these points here up with, what have they been joined up with?
Straight lines.
Straight lines, okay. Simpson's rule doesn't join them up with straight lines, it joins them up with quadratics. Yes, it joins them up with curves, okay. So if you think, if you put a curve in there, maybe I could have put that curve in, or that curve in, or that curve in. It makes it better, and it reduces the amount of overestimate and underestimate you've got. That is basically what it is. So, if I do a slightly better sketch down here, which I suggest you do, we're going to have...
C3, C4, C3.
This is C3, chapter 12. Okay, here we go. We're going to try and do that integration between there and there. I'll call that A, I'll call that B, I'll call that my function, x-axis, y-axis. Would you like a red box rule for this?
Yes, please.
You'll have one. Well, it's a sort of red box rule. It's a red box steps as well. Step 1. Divide your interval into an even number of equal strips. So if I start doing this here, I'm going to have some strips in here. Then I'll just put dot, dot, dot in. I'm not going to do this all the way. Ooh, that line isn't supposed to go like that. That's supposed to be a straight vertical line there. Really put me off.
It's pencil the best.
So, I am going to call this A x0, and then x1, x2, x3 and so on. I'm going to call the endpoint xn, so that'll be xn minus 1, that'll be xn minus 2 and so on. Can you remember, I think we used the same letter in the trapezium rule, what this gap is going to be called?
H.
H, yeah. Whether that H originally came from H for horizontal gap or not, I don't know. But H is the horizontal gap. So the main thing there, when you're doing that, it's got to be an even number of strips.
So, do you mean by even number of strips, do you mean evenly spaced, or do you mean
I mean
even number?
That's 1, 2, 3, 4, whatever that number finishes up with, that's got to be an even number.
Oh, okay.
Okay? So for example, you might have 6 strips, 8 strips, so on.
So they have to be equally spaced as well?
Yep, they have to be equally spaced. Okay? So into an even number of equal strips. Okay, so that equal strips there, that's the equal width. Okay, equal width strips. We'll put the width in there, you can do. And then there's this magic formula. Okay, this is step 2, magic formula time. Which will look a bit weird.
Why what?
Ends, odds, and evens. Now, I'm just telling you that formula is there. I'm hoping some of you will be thinking... What am I hoping some of you will be thinking?
What does that word say after Y?
We've got ends, odds, and evens. What will I be hoping some of you are thinking?
What those things are.
Sorry?
What those things are.
What those things are and where does it come from, okay? I cannot explain where that comes from any better than the textbook. What I would like those of you who actually bother about where things have come from to do is actually to go to the textbook, chapter 12, and it explains, and it's quite detailed, quite algebraic, where all of that I've just shown you comes from. But I'm not going to go through that now. What I've just written down is that bit there, okay, which they eventually come up with. If you want to know the why, it's in the book at chapter 12 in C3. Right, let's try and see what this means. Y ends means the Y values that go with x0 and xn. So in other words, it's that value there will be y0 when you read off on the y-axis. So that's one end of my integration. The y at the other end will be the y value above xn, be the height of the function there. In other words, the value of the function there, that will be xn. So you do the y values of the ends. Then you do 4 times by the y value of all the odds. Well, the odds are going to be the y values that go with x1, x3, x5, and so on. So y1 will be the height of the curve there. y3 will be the height of the curve there above x3. Happy so far? So, do I need to explain what the evens are? What are the evens going to be? Yeah, it's the y values that go with the even x's, x2, x4, etc. It's their y values. There's one thing I haven't explained where it is and where it comes from. What else is in that formula that you don't know what it is at the moment? Maybe you do, I suppose. I did sort of say up here. The h. The h equals the width of each block. And how could you work out what that h was going to be? How could you work out from my diagram there the size of h?
B minus A over n.
Yeah, it's b minus a, that's how wide the total thing is, divided by the number of strips you're splitting it up into. So that's right, h is b minus a over n.
If you're doing this and when you said that you represent it with a curve, so I mean each individual trapezium is represented with a curve on top.
Yeah, well, what would have been our trapeziums, yeah, each of them has now got its own little curve that suits it best at the top. I'm going to stop the video there.